A car of mass 1,600 kilograms is moving along a straight road with a speed of 90 kilometers per hour when the driver brakes. The braking force is 32,000 minus 12,800 T, which is the force measured in newtons, where T is the time in seconds after the driver applies the brakes. Calculate the time after which the speed of the car has been reduced to 57.6 kilometers per hour and the distance travelled in this time. Now, a fun thing that the textbook doesn't mention anywhere that I can figure out is that when you're doing these questions, if time is given to you in terms of seconds, then xt is a function, or your displacement function is going to be given to you in meters. Okay, so up here, 90 kilometers per hour, we're going to have to do some conversions for that one. But first things first, let's break down the question. So a mass of 1,600 kilograms is our first important information. Along a straight road at a speed of 90 kilometers per hour when the driver brakes. So 90 kilometers per hour when the driver brakes. So you could count that as being his initial speed, because that is when time is equal to 0, then his speed is equal to this. Now we're going to have to do some conversions to make sure that this is all in units of the same, because we want it to be in meters per second, but we'll come back to that in a second. Okay, the braking force that's applied is this. So our force is equal to 32,000 minus 12,800 T when the driver applies the brakes. Now he's braking, which means that acceleration is negative. He's going to be decelerating, not accelerating, which means he's getting slower because he's applying the brakes. I tried to do this without using acceleration as being negative, just to test to see if it would work. You do have to make it a negative, otherwise you'll incur errors later on. Okay, so first things first, we want the time after which the speed of the car has been reduced. So we want the time when the speed, or another way you could write that is like this, is equal to 57.6 kilometers per hour. Okay, so first thing we're going to do is we're going to do some conversions to get this into the units that we want. Just because it will make our lives easier just to throw some numbers in later. So if I've got 90 kilometers per hour and I want to get to meters per second. Kilometers to meters means I multiply it by 1,000. To get from hours to seconds, I first need to go to minutes. So there are 60 minutes in an hour, so I need to times it by 60 first. And then there are 60 seconds in a minute, so I need to times it by another 60. So that means that my 90 kilometers per hour is going to change into, let me find my calculator. Is going to change into 25 meters per second. Now, when I do the same thing to our 57.6 kilometers per hour, that's going to give me 16 meters per second. Okay, so now everything's in the units that we want. We can start doing some actual maths. So first thing we're going to do is force equals our mass times the acceleration. Now, our mass here is 16,000. Oh, no. Scratch that one. 1,600, and our acceleration is negative acceleration. So that is equal to our force, 32,000 minus 12,800. And what I'm going to do is divide all of this by the 1,600. I'm going to divide it by the negative as well, so I'm left with just A on its own. So that's going to give me negative 20 minus, plus 8t. Okay, and that symbol can be shown like this. So we've now got a function for our acceleration. We want to integrate this so that we can start to get a function for speeds. So we're going to integrate our acceleration function, and that's going to give us a speed or displacement function. So, and that's being integrated with respect to t. So integrate the negative 20 plus 8t with respect to t, and that's going to give you negative 20t plus 4t squared plus some constant. Okay, so now that I've got that, I am going to substitute in my first piece of information to work out that constant. So that first piece of information that I've got is when our time is equal to 0, our speed is equal to 90 kilometers per hour, which really means that our function of xt is equal to 25. So all I have to do is chuck those values in. 25 equals negative 20 times 0 plus 4 times 0 squared plus some constant, so our constant is equal to 25. Now I've got a function for our speed. So the function for our speed can be given as, I'm going to restate it like this so that it's in the correct order for our polynomial function. But that's the function that we've got for the speed of the car. So now we can start solving for the time after which the speed of the car has been reduced to this. Now, we already converted this number to 16 for the meters per second because this notation means that we're using meters per second. I'm pretty sure that can be given as a standard. Physics people might be able to correct me later on. Okay, so now 16 is equal to 4 times 0 squared minus 20 times 0 plus 25. Oh, wait, sorry, we're solving for the time. It's not given to you as 0. So we're leaving that as t. That means we're going to move the 16 to the other side to turn this into being a quadratic. Now we're going to go through how to factorize a quadratic because after watching some people in methods, I think it's probably something that we can practice. Okay, so when I've got a quadratic function like this, it's got to add to give me negative 20 and it's got to multiply to give me positive 36. So let's go through the factors of 36 and you should see that it's 2 and 18 pretty quickly. Because this is negative, they both have to be negative. They'll multiply to give me a positive, which checks all the boxes. Now, what this really represents is this number here being split. So minus 2t minus 18t, and then I can put the rest of the equation back in around it. Now I'm ready to start factorizing. So the number that these two share is going to be 2, and they share a letter of t. So when I divide, let's try writing that again. That's turned out horribly. So 2t bracket, I'm left with 2t minus 1. Now for my next one, I can factorize out negative 9. So when I factorize negative 9 out, I'm left with 2t minus 1. Make sure that this bracket matches that bracket, and then that's how you know that you factorize correctly. That means that my first bracket is equal to is 2t minus 9, and my other bracket is 2t minus 1. From this point, I can use null factor rule to work out what the times are, and we're going to look for the one that happens first because of the way that the question is worded. The other thing that we have to look for is it's the first positive number. So if one of these works out to be a negative, that's no good, we don't want it. So 0 equals 2t minus 9. That means that t is equal to 4.5. And for the other one, 0 is equal to 2t minus 1. So t is equal to 0.5. This number is the one that would happen first, and it's positive, so that's the one that we're going to take. So therefore, the speed is reduced to 57.6 kilometers per hour when the time is equal to 0.5 seconds. Okay, the distance traveled in this time. All right, cool. So the next one we're going to do, we are going to, if I can figure out how to get this per, there we go. We're going to integrate that function, okay? And then that's going to give us a function for the displacement. So next thing we want to do is we want xt is equal to the integral of our speed function with respect to time. So that's going to be the integral of 4t squared minus 20t plus 25 integrated with respect to t, which is going to give me 4 over 3t cubed minus 10t squared plus 25t plus some constant. Now we can use that piece of information that we're given, that when, oh no, let me read this question again to make sure that we've got everything. Okay, so the other thing that we do know from the question is it tells you that you just brake at a certain point. So if we're looking at the distance, think about your journey in the car. Here we are. That's where we brake, okay? The time when we brake is 0, and when you brake is when you start. So that is also going to be 0 if we're just determining the distance between the 2 points. So that means that when t is equal to 0, xt is also equal to 0. So now I'm going to let this function equal 0 and solve for c, which is going to give us that c is equal to 0 as well. Once I make this 0, and this 0. Okay, so now I can state what my displacement function is. So it's going to be 4t cubed minus 10t squared plus 25t. Okay, so we want the distance that it travelled in this time. We already know the first one. So when our distance when time is equal to 0 is 0, and we want our distance when time is equal to a half. So now we have to substitute a half in there. So minus 10. Now, I think I'll do this by hand at the moment, and we'll see how far through we get. I might need a calculator. Just remember that when you are looking at the powers on the outside of a bracket and there's a fraction on the inside, the power will multiply both the top and the bottom. So the first one is going to be 4 over 3 times 1 cubed is 1, 2 cubed is 8, minus 10 times 1 squared is 1 over 4, plus half of 25 is going to be 12.5. Okay, so now I can break these numbers down further. So that's going to be 4 over 24, which can be broken down more into 1 over 6 minus 2.5 plus 12.5. So that is going to give me 10 and 1/6. Okay, so that means that our thing has travelled for 10 and 1/6 meters before it stops.